Okay, now we're going to talk about the law of cosines. The law of cosines is applied when we have side, 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 and side, angle, side. Again, this is just one law. There are different ways we can rearrange the law, but it is one law. Think of it as one law to rule them all. Anyway, so here it is, just rearranged in different ways. So if I want to solve for a side, then I can think of it as a squared equals b squared plus c squared minus 2bc cosine a. If I take this equation and I just algebraically rearrange it to solve for cosine a, I get this. Same thing here for b, cosine b, c, cosine c. Again, these are not different laws. They are all the exact same thing. You're just switching the location of variables or algebraically rearranging things. Same one law to rule them all. Let's prove it. Okay, there is, I believe, a proof in the book, but here is another proof. So if I have this triangle where I have angle A, side A, angle C, side C, angle B, side B, let's draw in an altitude. So I'm going to call this Y. This is the point D. So now this segment here is X, and this segment here is A minus X, because remember the whole length of the side here was A. So now I know that c squared equals a minus x squared plus y squared. That's just Pythagorean theorem. And then I also know that the cosine of c is x over b, because that's adjacent over hypotenuse of this right triangle. And the sine of c is y over b, again, just right triangle trig. So if I rearrange those, I get x equals b cosine c and y equals b sine c. So now, voila, I get that c squared from up here equals a minus, and remember that wasn't x, but we substituted in b cosine c squared, plus y squared, but y was b sine c, so I substitute that in here. Now distribute this, combine like terms, and I get the law of cosines. C squared equals a squared plus b squared minus 2ab cosine c. Awesome. Great. Wonderful. Okay. So we want to solve the triangle, find all of the missing sides and angles. I'm given a side A, side B, and side C. I want you to go ahead and try to do this. There are a couple of different approaches you can take. You're going to have to use the law of cosines, though, that's a given. A hint, if you are going to switch to the law of sines once you find one of the angles, then you must find the largest angle first. If you choose not to switch and just use the law of cosines again, you don't have to worry about it. So that would be what I would tell you to do. Just use law of cosines twice, find two of the angles, and then subtract from 180 to find the third. But if you want to switch to law of sines, you can, but you have to find the largest angle first, otherwise you will potentially, not always, but potentially create a false triangle solution. Okay, so go ahead, pause the video, and try to do this. Alright, so here I chose to find angle C first. So I did cosine of C is 55 squared plus 25 squared minus 72 squared over 2 times 55 times 25. The most difficult part about the law of cosines is typing things into your calculator correctly. I lost glitches in the program. Alright, so cosine C. So if I type this into my calculator correctly, I get negative 0.558. Cosine inverse is 123.905 degrees. Then I went and used the law of cosines to find angle A, doing the same thing, and then I actually did it a third time to find angle B. It's just calculator work at this point. Now, once I found angle C and angle A, I also could have done 180 minus angle A minus angle C to get angle B. Either way, I would get angle B to be 16.749 degrees. Again, so as long as you are typing things into your calculator correctly, law of cosines, just stick with it. It's easier than trying to figure out, okay, wait, did I need to find the largest angle or the smallest angle? I don't know. Anyway, moving on. So now I want you to solve the triangle. Here we are given side angle side. So this is going to be slightly different. Again, I would recommend just stick with the law of cosines. But if you choose to switch the law of sines, then you're going to have to find the smallest remaining angle after you first find the missing side C. So in this case, we have to find side C first based on the given information. Once you find side C, now you need to find angle A and angle B. If you choose to switch the law of sines, you will have to find the remaining smallest angle. Or you could just use law of cosines again. Pause the video, find the missing pieces, unpause when you're ready to check. Alright, so for good or bad, with the side angle side scenario, we don't have a choice at first. We have to find a side because we only have enough information to find, and in this case it was side C. So I did the law of cosines to find side C. Again, as long as you type this into your calculator correctly, don't try to take shortcuts. For this one especially, type this entire thing into your calculator exactly as it's written. If you try to do your own order of operations, you're gonna maybe mess it up. So don't mess it up. Life lesson. Don't mess it up. Alright, and then I get side C is 4.214. Again, if we had units, we would want to make sure we put units. So I'm going to use that and the other given information. In this case, I chose to find angle A because I don't want to switch to law of sines. So I found angle A, typed this into my calculator correctly, so when we're typing this in, put this entire thing into your calculator exactly as it's written, except put parentheses around the entire numerator and parentheses around the entire denominator. If you do that, it'll be good. If you don't, again, what did I say? Life lesson, don't mess up. Alright, so I get angle A is 157.020 degrees. Now I know side C, angle A, angle C, so I can find angle B, which is the remaining missing angle, by subtracting from 180, and I get 7.73 degrees. That's the law of cosines. But again, if, and only if, you choose to switch the law of sines, you need to follow these rules.